Hi, my name is Marc Holbach, and I'm the Technical Consulting Lead here at Software Toolbox. Today we're going to take a look at the new OPC UA standard that is replacing OPC DA in many automation applications. What is OPC UA? OPC UA stands for Unified Architecture, and it was a collaborative effort of the OPC Foundation started in 2004 with the objective of creating a standard that was not dependent on DCOM, something I'm sure we've all had issues with and hate equally. Another driving factor for moving away from DCOM was a desire to be able to run OPC UA servers and clients on non-Windows based operating systems and allow all these different applications out there to communicate with each other, something that was previously impossible while being married to Microsoft technology like DCOM. OPC UA also provides a much more secure platform for exchanging data, and there was a desire to remove a lot of redundant code that currently exists in the OPC specifications. The majority of users in the current OPC market are using OPC Data Access or OPC DA. There's a few out there using alarms and events or OPC A&E, and then there's even fewer using historical data access or OPC HDA. All the standards the Foundation created had many things in common, but actually used zero common code across all specs. OPC UA adds a common interface to all of these standards, which makes it much easier for vendors to implement multiple standards. Let's look at an example of what I mean by this. The OPC Foundation is now calling any OPC before UA OPC Classic. In OPC before UA, there were a lot of different interfaces just to read data. In OPC UA, all these calls get consolidated to two, read and read history. Based on the attribute and profiles, the server will know how to respond to the request. Another benefit to using OPC UA I mentioned is security. With OPC UA, servers and clients can authenticate each other by using TLS or transport layer security. Naturally, you want your data not to be able to be intercepted or altered easily, particularly when transferring data across a public network. Of course, you also want that data to match what was sent by your server. A common hacker technique is to do what's called a man-in-the-middle attack, where someone will get in between the client and the server and intercept the data packet sent. Once intercepted, data can be altered and forwarded. You can imagine what adverse effects this could have on an industrial control environment. When they look at the added security in UA, they wanted to be able to withstand a variety of different types of common attacks. OPC UA data is transferred using TCP/IP and uses TLS certificates to encrypt the data and authenticate endpoints. The certificates can be generated by most OPC UA clients and servers. The clients and server must share their individual certificates so that they know how to decrypt the data that is being received. UA is also capable of using public certificate authorities like VeriSign. The trend we are seeing is that most vendors are self-issuing these certificates. A certificate can represent a client or a server. For a UA server to successfully connect to a client, it has to trust that client certificate. A certificate also represents a person or a login. The key is that these certificates are unique and practically impossible to replicate. The whole concept of a trust list is that the client and server maintain a list of authorized connections. Clients and server must therefore be added to each other's lists before they're able to communicate. When the client asks to connect to a server for the first time, the client will give the server a copy of its certificate, which will then be compared to the certificate in the trust list. If it does match, the server will send back a copy of its certificate to the client. The client then checks its trust list to verify that that certificate exists. They are now communicating using secure connection. If the certificates do not exist in each other's trust list, the connection will be blocked and will not be possible. We already talked about the unification of the OPC standards a little. We've talked about security, but the biggest value in using OPC UA is probably that it does not require DCOM, but instead uses web services and TCP/IP calls. It uses a single TCP/IP port that is user-defined and much to the joy of many IT departments, I'm sure. The ability to have a UA server on a mobile device or any non-Windows platform really, talking to a client at the enterprise level using simple but very secure TCP/IP calls allows OPC UA-enabled servers to provide data to a much broader assortment of clients than any previous OPC standard did. Let's take a look at some terminology specific to OPC UA. In OPC DA, you're very familiar with the term tag. This has been replaced in OPC UA by the term node. Variables in OPC UA, such as value, quality, and timestamp, are known as attributes in OPC DA. An OPC UA node or tag name, there are attributes such as value, quality, timestamp, as well as other attributes like scaling, engineering units, etc. It's really all the same stuff we had in DA, just different terminology. Instead of having a tag with attributes, we now have a node with variables. The OPC UA standard is made up of several different profiles, and I'll get a little bit more into what exactly a profile is. A profile is a block of functionality that makes up an information model. OPC Data Access is an example of such a profile. OPC DA profile of the OPC UA standard is what almost all vendors who've adopted OPC UA are implementing. Since OPC DA currently accounts for around 95% of all OPC users, this is a safe bet. Profiles are a way for clients and servers to ask each other, do you have the functionality that I need? If you have a client application that only supports the OPC DA profile, then you should find an OPC UA server that also supports the DA profile. The same can be said for other profiles like HDA and alarms and events. So in summary, nodes make up information models. Profiles tell the clients and servers what information models are available. Most OPC UA products that are currently on the market are using the OPC DA profile. The majority of vendors are adopting UA, so why should you consider making the switch to OPC UA? Number one, hands down that there is no DCOM required. I've been supporting DCOM for years now and would say roughly 20 to 30% of my troubleshooting efforts have been DCOM related. If you translate that into dollars, that is a large chunk of money that could be saved by using UA. You and your users will spend much less time configuring remote OPC connections. Instead of DCOM, it uses simple TCP/IP connections that are firewall friendly and through its use of TLS and SSL, encryptable and secure. Because UA uses simple TCP/IP calls and doesn't rely on the COM architecture, it's also platform independent and will allow you to share data with clients or servers running on non-Windows platforms.